Microphone check. I do believe we're up and running. Stream health is orange. Check resolution. Huh. I'd say that's optimal. What's going on, guys? Been a little while since I've been on the stream. Now, this is a daytime stream, which I have done less of in the past. Usually the live streams have been all up in the evening over here in the UK, which equated to like late afternoon in the States. So these daytime streams, they tend to get a different viewer base than the evening streams that I do. I tend to get a lot more viewers from Europe at this time of day when I stream, because it's more similar to the kind of time that it is here. And obviously people work different shifts in their job, people have different days off, etc. So I thought, why not? I've got an amplifier here that's pretty jank. It's yeah, needs quite a bit of work on it, I think. So I thought, why not do a daytime stream that hopefully some of you guys that can't always catch the late night ones should be able to tune in. Man, you can tell when the notifications came through, because literally I was probably streaming for about 2 minutes and it was all on 0, wasn't getting any messages, and then literally the second that obviously the delay on the notifications going out comes in, the live chat blows up. Hello, what's going on too? Oh, okay, streaming. Vladimir, 13BT, Chris, Billy, Savage, Prankster. Hi, what's going on? What's going on? Da Lennox, Basehead, yo. All you guys up in the live chat, how's it going? It's good to be back. We've got viewers from Sweden all up in here. We got viewers from Teesside up north. Let me know where you're watching from, guys. Be interesting to see how far the reach stretches. Yeah, that's so behind me, if you haven't noticed, there is an RE XXX V415. Really nice piece of kit. It's not an SPL monster as most people believe it is, or what it looks like. It looks like it's a absolute beast of a subwoofer. You know, high power, high SPL thing. It's actually not. It's very much a kind of SQ small sealed enclosure, small vented enclosure woofer, and the most that you want to really run it on is about 1600 watts RMS. You don't want to put much more to it than that. The coils are actually pretty small and can't take a great deal of power. It's just meant to be a really lovely sounding musical sort of woofer. We've got Mexico, got right over in Mexico, got Germany, Bulgaria, Texas, USA, South Africa. Yeah, so the reach is worldwide. Carolina. How are those DDZs? Yeah, they're doing really well. They're still breaking in, so the idea is to get them broken in a little bit more, and then I'm going to go ahead and put them on the meter. I haven't even put them on the meter yet to see what they're doing compared to the 35s, so that's coming up. But it's been really shitty weather here. Not really good weather for doing like a bass video, you know, because I need the doors open or the windows open, and it's been pissing with rain and freezing cold. So I'm going to sort of break them in over the next few weeks. Hopefully I get a nice day with a bit of sunshine. I can go down to the industrial estate and crank them up for you, get it on a video, get some more hair tricks. I've been taking like lots of hair trick videos here and there, like when I've been out and about with my own friends or like at small car shows in the UK, and getting some cool videos of hair tricks and stuff. So they're very, very windy, and they're getting louder the more they break in. So yeah, that's pretty cool. There'll be some nice videos of the Zeds coming your way for sure. I've also wanted to do a video for quite a while now on, this will be more of an educational video about amplifiers and running at 0.5. So if you're members of any Facebook groups or forums or anything like that to do with car audio, then at least 10 times a day there'll be different guys up on the group posting, oh, what do you guys think of X amplifier? Can it run 0.5? And people, you'll get the answers on there will be like, will be yes, provided your electrical is strong, or no, I wouldn't recommend it on that amplifier, or yeah, that's a really solid amplifier, 0.5 all day. Then you'll get the guy who comes in, yeah man, I run mine at 0.5 for 3 years, barely got warm. And then you get the other guy that was like, yeah, I ran it at 0.25, etc, etc. So that's how it kind of goes down on the forums when people ask about wiring your amplifiers to 0.5. However, this is not truly correct advice. Any of those answers are truly correct advice. The correct answer to will this amplifier run 0.5 wired at 0.5 is yes. Every single amplifier, every single 1 ohm mono amplifier in the entire world will run 0.5 ohm all day long happily, if the subwoofers and enclosure setup are efficient enough to cause enough box rise. So people shouldn't be asking, is my amplifier capable of 0.5? They should be thinking, my amplifier can be wired to 0.5 all day if my subs and box are efficient enough. So they should rather be asking the question, guys, are my 2 subs in this enclosure playing these sorts of frequencies tuned to this frequency going to be efficient enough to run my amplifier at 0.5? That's the question that people should ask, because it's not down to the amplifier that you run, it's down to the subwoofers and the enclosure and how it's all set up as to whether it'll be happy at 0.5. And so I'm kind of bored of writing that on. I mean, okay, obviously there will be certain amplifiers that are built better and stronger than others, so they would be better. So if, for example, there wasn't much impedance rise and the amplifier saw under 1 ohm for long durations, there are some amplifiers that would do better and last longer than others in that situation. However, for running music daily, and you know, where someone's asking, is this safe to do on my amplifier all day long for years and years at 0.5, then the question, then the answer lies with the subwoofers and enclosure used rather than specifically what amplifier is used. Because even if you have a really good strong amplifier, a really reputable overbuilt amplifier running at 0.5, a continuous 0.5 load on pretty much any 1 ohm amplifier, a continuous static 0.5 ohm load, so you know, if it was actually seeing 0.5 after all the rise and stuff like that, it is not going to last. It might last a few weeks, it might last a few months, but it's not going to be happy and it's going to get really hot. And as amplifiers get hot, the current capabilities of the MOSFETs goes down the drain and you get all sorts of issues. So yeah, even with the best amplifiers, even with the best car amplifiers in the world, they don't like a actual reactive 0.5 ohm load. You've got to try and get it up at 1 ohm somehow. Thanks for the head unit repair. It works. Oh shit! So I don't generally do head unit repairs, but I did a repair on I can't remember what brand it was, on a head unit for the Speaker Freak in the live chat here. He sent over. Wait, what the fuck's going on? Why is it? My mouse is like desynchronized. Look, I'm trying to highlight up here and it's highlighting down there. Anyway, yeah, I tried to. I basically sent over a head unit motherboard without any of the casing or anything, just sent the circuit board over, and a capacitor had exploded onto the circuit board of the head unit, and it had been left for, you know, capacitors, the electrolytes in capacitors, when they explode over a circuit board, especially a circuit board that uses really tiny surface mount components and chips, that electrolyte eats away at the legs of the components, like the chip legs and other things like that, and it eats away at the traces on the board, and it can be a nightmare. So he sent it in to me, and I replaced the cap and I cleaned it up, and I noticed that it had eaten one of the legs of one of the main chips of the head unit. So it was really difficult because it was absolutely microscopically tiny, this chip and the legs on it, but I ran a jumper wire from what remained of the leg that hadn't been eaten by the capacitor gunk, and I ran that wire to where it should be on the board, and I was like, dude, I have no idea if this is going to work, because, you know, what the hell, I didn't have the rest of the board to test it with. He just sent me the circuit board without any of the rest of the stuff, so I sent it back to him, and I wasn't expecting it to work, to be honest, but According to Speaker Freak, it done work good, so that's cool. Adam Francis, Gannon Boy, good to see you in the stream. Thanks for the help on the amp you gave me. Worked out perfect, says Simmons Home Design. Awesome. I'm glad that works out for you, my man. Always really nice to see my assistants going to good use somewhere and getting an amplifier up and running again. Sam, did you ever get the Hacko oh, what the hell? Sign into chat. Okay. Did you ever get the Hacko desoldering pump? I haven't got that yet, no. What the hell? I've just lost my live chat. Sorry guys, one sec. What's going on? Does that mean I've just lost all your messages? Ah, hell no. Oh wait, here we go, they're back. Did you get the cake I included? Yes. Speaker Freak included some cake with the head unit that he sent me, and I actually didn't realise he put cake in there, and so I left the parcel for 3 days, but the cake was well wrapped and I ate it, and I'm not dead, so that's fine. It was a fairly decent cake. Okay, so it's about time we explain to you what the hell is going on with this amplifier that I have on the bench today. So this is Ground Zero 4K, and this has been sent in by a customer over in Europe. I don't generally take work from Europe, but this guy insisted and insisted. He's happy to pay the postage and etc. And if there's any issues with the amplifier once it gets back, it's it's difficult to really send it all the way back again. So I don't generally like doing work for places in Europe, but this guy is sending me like lots of amps at the same time, like up to 6 to 8 or more amplifiers at the same time, which is saving on postage, so that works okay. So the issue with this amplifier is quite visible to start with. So we're going to first of all have a look, visual inspection. Stanky ass power supply. So if you ever see the smoke on the board or the black marks, that is the power supply section that's gone down. Now this amplifier, and this is another reason why I don't like doing work from Europe, obviously has been sent over from Europe, over the sea, over the British Channel and all that jazz, and this amplifier actually got wet somehow in the packaging. I don't know whether it was rained on or it was put in a puddle or something, but this amplifier was pretty soaking wet on the inside when I received it, and the cardboard box was wet as well. So unfortunately there are many places on the board that have like corrosion. There's like really orangey rusty corrosion on many of the vias and pads and traces. It looks nasty in here. It smells like a compost heap. So yeah, not ideal. It's not in the best condition. We're gonna have to clean this right up, and I'm probably gonna have to reflow most of the solder connections in here that I can see have visual signs of corrosion after we've let the isopropyl alcohol do its job to remove the corrosion. As you can see here as well, there's lots of black crap all going on around the drive circuit. It looks really dusty, looks like a complete mess, and I believe the power supply has gone down as a result of output section failure, because I checked this one earlier. So we've got a few shorted output MOSFETs on this amplifier as well that we need to replace, and because these output MOSFETs are shorted, it usually kills the very delicate drive chip on the driver board, which is an IRS 21844S. So there are 2 drive chips here driving each side, so we will probably have to go ahead and change both of those as well. One thing which is interesting that I don't think I've really mentioned very often on amplifier repair live streams before is that actually what we have here in a Class D mono amplifier is there are actually 2 amplifiers in this case that are running parallel with each other, not in series, so they're parallel together for higher current. When you open up a Class D mono amplifier like this, the number of output inductors that you see on the board is the number of parallel amplifiers there are in total. So here we have 2 output inductors, which means that there are 2 identical amplifiers run together in parallel, and they are brought together after the inductors, and then there's some circuitry here for further smoothing. You can even see the split down the middle here. You've got the inductor, and then this is some capacitors for this side, some capacitors for this side, further noise reduction, and then there's even a relay for each of the separate amplifiers, and after the relay they combine into a single speaker wire in parallel with each other. So the chip, the IRS 21844S chip, is a full Class D amplifier drive chip that gives a high and a low side, and you've got two of those, so there are literally essentially two identical amplifiers in here that are just brought into parallel together at the end. I mean, you could technically possibly turn this amplifier into a 2-channel amplifier by making some somewhat basic modifications. What you'd have to do is you would have to obviously give the driver board a second input for audio, because at the moment it only has one input pin. So what you'd have to do is you'd have to cut the traces and split off the inputs for each of the drive chips here. You'd need probably 2 separate Class D PWM generation circuits, so you might need to use 2 of these driver boards just to salvage the center gubbins of one of them, so you've got 2 channels. But then you can just use this chip and this side of the amplifier for one channel, this chip and this side of the amplifier for the second channel, and then just not combine them at the end here, have them running to separate terminals at the end here. Why would you ever want to do that? I don't know, but it's just a cool theory that could technically be done if you wanted to. It's either salt corrosion or it's just general rust, like, you know, just standard rust from lots of water and crap. Do these Ground Zero amps do rated power? Pretty much, not quite. This one is the old 4K. This is the 4000, or is this the 4K? So, as you can see, this is what this one looks like with the GZ on the front. I can't remember the exact model number of this. The model number is on the case, on the back case. I can't remember. I think this one's a 4000 GZP. Is it the Plutonium series? GZ, no, it's not. This isn't the Plutonium series. This might be the nuclear GZNW 4000 DXII. Ah, fucking the model number's huge. But yeah, it's supposed to be 4K, but from memory these do about 3.5. So don't quite do rated on these ones from memory. Yes, so what we're going, well, I'm just basically disassembling this amplifier as we speak, and then we can start work on firstly the power supply section and then the output section. I can't remember where. I think there are some screws that I've missed somewhere because this isn't coming out easily just yet. Let's have a quick look. So we took the ground screws out over here and over here. These screws for the fan I don't think they go all the way through the board, or do they? Maybe they do. Sometimes these fan screws go all the way through the board, and on other amplifiers they don't. Ah, no, that's pretty long. Yeah, that goes all the way through the board. That should be the last screw that I need to take out then. Let's remove the fan. They glue these onto the boards, and usually when you pull them out, the whole header comes with it, which is fine. Just leaves you the pins on the board. And now it should technically slide out. No, there's still something holding it in. There's a screw here that just doesn't quite want to come out. Greetings from Austria. How's it going? All the damage plus the water. Where do you draw the line and say not worth fixing? Well, this is definitely worth fixing. So a bit of water damage on here. There's very light water damage. Like, I've seen amplifiers that have very, very heavy water damage, and sometimes if it's not a very powerful or expensive amplifier and the whole thing has been sitting in water for a long time, and you know, even if you clean it up with isopropyl alcohol, pretty much all the traces themselves are gone or like heavily damaged, and you'd have to rebuild the amplifier from the ground up. Then it's not worth repairing. But this is a relatively, you know, this amplifier is worth a fair bit, and it's does fair decent power. It does a fair bit of power, and I don't think that this is going to be too complex of a repair, even with the water damage stuff. There's not much water damage, a little bit of corrosion on a few parts, so I don't think that this should give us too much grief. Wow, that's a nasty squeaky sound, isn't it? Okay. The wire for this head cam is really annoying. Okay. Oh, very nice. Thank you very much to Hamer Zef. Do you design T-line enclosure? I don't generally do enclosures, do enclosure designs, but I could give you a hand if you like. The best software for designing a transmission line enclosure is actually Horn Response. Horn Resp for Windows. It is a bit of a daunting program to get your head around at first, but if you stick with it and you learn Horn Response properly, it is a wonderful piece of equipment, piece of software for designing transmission line enclosures, horns, tapped horns, pretty much anything that uses a quarter wave for its as its base design. Fantastic piece of software. I could give you a hand if you like, but a basic T-line is very, very simple, but it can get very complicated if you want it to, and if you are really looking for the absolute creme de la creme in terms of frequency response and output and minimal harmonics. Afternoon, John Paul. How's it going, my man? Hope your amplifier is still going strong. It's Jeremy from Facebook that does the sound stream repairs. Glad to see you back online. Ah, nice one, the Discman. Good to see you on the stream. Thanks for tuning in. I had an argument about your channel Sunday night about what is the most brand amp you repair. What? Maybe that's meant to say I had an argument about your channel Sunday night about what is the most common brand amp you repair. I would generally say the most common brand of amplifier that I work on is either Bass Face or Hyphonics, I would say. Ground Zero is kind of up there as common. Right, so first things first, the power supply on this is fucked. So let's go ahead and just snap off all these power supply transistors, MOSFETs, so we can start work on this and see if the drive circuit got damaged at the same time. Have you ever played with Win ISD? I personally haven't played with Win ISD. I downloaded Win ISD when I was about 15 years old, before I really had a clue what was going on, and took one look at it and it scared the crap out of me, so I was like, fuck that shit, and uninstalled it straight away, because I was like, I had no idea what any of the TS parameters meant. And since then I got on really well with Bassbox Pro 6, and I've seen other people use Win ISD, and it probably has its benefits over Bassbox Pro 6, but BB6 plus like experience and knowledge like of these things is all that I've really needed to get good sounding enclosures that do what I want them to do. The problem with car audio and the amount of power that we're throwing at these woofers, and also the characteristics of these woofers, these programs, even BB6 Pro, Win ISD, all these things, they were never really designed to cope with predicting the characteristics of such ridiculously powerful subwoofers and amplifiers. They're really good for like hi-fi, home theater, and smaller, lower powered SQ kind of setups, because you can really fine-tune the enclosure to give you the response that you want. But when you're throwing that much power at it, the program falls apart a bit and doesn't always tell you, it's not always accurate as to what's actually going to be happening in the enclosure when you throw that much power at it. Especially in terms of cone displacement. It gets cone displacement wrong quite a bit. Having fun with the M4A. Good, I'm glad to hear it, man. The M4A is a lovely amplifier. I'm glad that it's sounding good and giving you lots of joy. That's good. Right, so this amplifier is in a really nasty condition with lots of black stuff. So what we're going to go ahead and do first of all is clean that up with some. And it's very important that if you're going to clean an amplifier board like this, if you're going to use isopropyl alcohol, it's very important that it is 99% isopropyl alcohol. Anything less than 99% of isopropyl alcohol has impurities in it that are conductive. As I found out, I bought some 97% isopropyl alcohol a while ago because it was cheaper, and I noticed that actually it had a resistance, and if there was any left on the board that was still wet, even the slightest bit of damp moisture, any slight isopropyl alcohol left on the board, it was actually conducting between pins of chips and stuff like that, which is not ideal. So you have to be using the proper stuff, 99% pure as you can get isopropyl alcohol to do this. So I'm just going to spray. I've got it in a spray bottle for convenience. I'm just going to go ahead and spray up the board here just to get rid of the majority of the black stuff. It won't get rid of all of it at first because I've still got resistors and legs and stuff on here, but I just want to try and see whether the board itself has been damaged and is carbonized, or whether it's just soot laying on the surface of the board. I think by the looks of this, it's just soot laying on the surface of the board. As I'm sort of cleaning it and rubbing it here, it's actually coming up quite nicely. So I'll get the worst of it off with the towel, and then I'll go ahead and use the toothbrush to get in these tight spaces to clean up the rest of it. I just want to make sure that there isn't any large sections of the board that are carbonized, because that's a pain in the arse when that happens. Which amps do you repair the least, even though they might be very active in the community you live in? Good question. I'm trying to think of an amp brand that there are lots of floating around that I don't generally touch a lot of. Well, I'll tell you one of the most crazy ones, and that's LW Audio. So LW Audio is the brand that myself and my business partner in Sweden, Lawrence Rasterson, he had these amplifiers made over at Zenon factory in Korea, and I jumped on it and distributed them to the UK for a bit, I mean, there's not like absolutely shitloads of them floating around the UK, but there are quite a few of these LW audio amplifiers in the UK, and those that are in the UK are they're abused, like, you know, they're used properly. They're ran at 0.5, they see like 9-10 volts sometimes with the people that use them, and, you know, they're strapped at sort of 0.5 and all sorts of things, and they're actually the amplifiers that I'm using in the van, the LW Audio 4.5Ks, and for the duration of the time that they've been in the UK. So I think there must be over 200 or 300 amplifiers in the UK, LW audio amplifiers, and they've been in the UK for about excuse me, for about 4 years now, all different models, and I have never ever seen or heard of one that has blown or has needed repair. It's pretty crazy. So yeah, that's the 1600 watt bass amps, the 4.5K bass amps. You got the 4.85s, the 4.125s. You know, and if they had gone down, if one of them had blown, I imagine I'd be the first to hear of it because I sold it, or because I'm the only person that's really repairing these things. The only other person in the UK that repairs these car amplifiers that I am aware of to any level is Gordon at the Amp Doctor, and he's pretty much passing most of that sort of Class D stuff on to me now anyway, so he'd probably message me about it and see if I wanted to take on the job. So yeah, I have never seen one of those LWs blow or gone down in any shape or form, and considering how they're used, that's very impressive. Oh, Simmons Home Design for the $10. Thank you very much, my friend. Massively appreciated. Cheers for the small tip there. Do you have an opinion on Planet Audio amplifiers? I've only ever worked on one Planet Audio amplifier, and it was a 2-channel Class AB. It was nothing crazy special, but it was a pretty decent, like, beefy board. It did good power, and it was pretty clean output as well. So yeah, you know, not too bad based on that one amplifier that I've seen. Yeah, so if you can get it for a cheap price, it should be a pretty good buy. Use your hot air station to dry the board after using 97% alcohol, and then every time, and then no worries. Yeah, but I found that the whatever it left on the board, the remnants, the impurities that it left on the board, they were conductive too. So even after it was completely bone dry, there was still some risk of conductivity on the board. So I'd rather just not use it. Mega Hatcher is sat in Lawrence's caddy. Man, I'd love to have a sit in that. I will definitely be going over to visit him in Sweden this year. 2019, I'll go and visit him. Yeah, I burnt a smiley face in my desk when I was bored one time with my hot air gun. So Seth pointed that out. What do you think of the 7500 dB drive? I haven't had experience with that. It's not a brand that I've ever seen in the UK, so apologies. If you could send me a picture of the board, of the guts, I can probably tell you whether it's any good. What do you think of the Orion HCCA 150R? I found one in my car, new condition. I'm not familiar with that model because we don't get a huge amount of the Orion stuff in the UK. The stuff that we do have is just the HCCA amps and the D5000s, D2500s, and some of the new full bridge amplifiers that they've made. I'm just going to go ahead and Google search that. What is it, a small amplifier? Or is it a large amplifier? What is it? 150R. I'm just quickly checking out the board layout here. So it's a Class AB, looks like a 4-channel, perhaps. I haven't had any experience with it myself, so it'd be difficult to give you an opinion on that one without actually having looked at it myself. But the Orion stuff is usually pretty solid, so yeah, it should be pretty decent. Greetings from Durban, SA. Sam, have you or others in the chat clamp tested a Cactus Sounds? No, we don't get Cactus Sounds in the UK, sadly. Sorry, man. There's lots of brands that you guys will ask me about that I won't have ever seen or had experience with because we don't. That's not a brand that we get over here in the UK, really. So yeah, apologies. Cactus Sounds. I'm trying to think if there's any. If I've heard of any good or bad words to be said. I'm pretty sure that Cactus Sounds amplifiers have been used pretty high up in the competition scene with pretty good results, from what I remember, possibly. Cactus Sounds themselves won't have done any amplifier board design, so it will be a generic board layout, but whether it's a good one, a good build, or a poor build, which factory it was made in, to what level it was made, what components they used, etc., that all varies between amplifier brands, even if they're using the same basic board layout. I'm just trying to get in here and clean up as much of this drive circuit as I can from all the soot and dust and crap, and then we'll go ahead and see whether there's actually any drive waves on here. And I think I'm also going to refresh some of these solder connections. So if I just take my zoom in, my head cam here, and zoom in for you guys. So around the you can see here resistor, what's that, 61A there. You see how there's like some corrosion. I don't know whether that's the corrosion has eaten the solder or whether there just wasn't any there to begin with, but because there's a trace coming off the top here, I am just going to go ahead and lay some solder down on the top of this board in case the vias have been damaged by the corrosion due to liquid or whatever this crap is that's around here. So I'm going to go ahead and take my iron just now and put some fresh solder beads on some of these resistors just in case there's any poor connections there. What's up, Modbox? How's it going, man? Yeah, fire away. What's your question, sir? How do I send you a pic? Simmons Home Design, if you want to send me a picture, just go to facebook.com/bearvids and you can send me a picture on chat. You can send me a message and include a picture in the message. Corey Jones has a full build with Planet Audio and it does pretty well for me since it's pretty unknown in the Caribbean. That's pretty nice. I haven't personally seen any Planet Audio subs or anything, so that's pretty cool. Would you ever look at some Audison amps? Yeah, I've looked at 1 or 2 Audison amps before. They had silly little issues like single diodes or things that had failed. So yeah, I'll never say no to looking at a certain amplifier or whatever. Unless it's something that I know I can't get parts for or that I know I can't repair. Yeah, see, the solder is not really taking to these traces, so I'm wondering whether this is actually corroded beyond just putting new solder on the top here. I'm just letting the flux inside the wire do its job here for a minute, and if need be, we'll go further with it, and I'll have to run some jumper wires. I don't even know whether these are making a bad contact yet or not, but they look really bad. So I'm just kind of doing a little trial test first, just to see whether the solder will stick to anything that's left there. So if it doesn't stick, then there's obviously nothing there that's usable. What do you think of in-phase amp board structure? The in-phase amplifiers, some of the bigger ones are actually similar board layouts to a lot of reputable brands, but they never make their power that is on the case. So the in-phase IPA 4000 I think makes about 2500 watts at 1 ohm, which for the price that you can pick them up for used is quite respectable. It's not too bad. So if you can find one at a really cheap price, it will do you quite well. How's it going, Jim? How's it going, my man? The B2 monos are still going strong. Ah, that's really good to hear, especially after the issues that we had with one of them, I think it was. So I'm glad that that's still going strong, my friend. Yeah, see, I'm not liking how the solder is not really sticking like it usually does to these vias and stuff. So what I might do is, I'll test it out first. I'm going to plug it in a second. I'm just going to run the power supply drive waves. If there are any issues, if it doesn't look right, even after we change the drive transistors, then what I'm going to do is I think I'm just going to go ahead and pull every single component in this section, clean up the traces, clean up the vias, and freshen it all up with brand new components. It's going to end up costing the guy quite a bit, but I mean, with the condition of some of these vias and traces, that's really the only way to guarantee a reliable repair. Okay, right. Let's put some power into it and see whether the drive transistors have survived or not. B4M Boo! Greetings from Germany. Thank you very much for the kind donation there, my friend. If you've got any questions or anything, man, if you want any assistance with anything, then give me a shout. I'll be more than happy to help you out. The board is not really top notch. Had to throw two of them away due to exploded power supply section. Board was conductive all over the place. I agree, Vladimir. These orange coloured boards are very susceptible to carbonization from excess heat when the power supply fails. I've seen many of these that I've had to literally cut away huge sections of the board to get them back up and running again. They're not very nice build quality. So yeah, no wonder you had to throw a couple of them away. Modbox says part numbers on their black. Hang on a minute. Maybe I've missed. Nope. Modbox says, here we go. I've got that Korean 3.5K together. It has those waffle bootstrap parts. What? One is previously cracked. Oh, I know what you mean. I got the bootstrap resistors, but them flat brown two-leg parts I can't seem to figure out. The part numbers on the blank two legs part this. What? Hang on. Sorry, man. I'm struggling to make out what this says. Part numbers there. Part numbers they're blank. It has two legs, two leg parts. There's 6 in total. Bootstraps on the 1405s. So the 14, that's power supply fetches on the power supply section. So he's talking about bootstrap components for the power supply section. I'm not sure what you mean by those waffle bootstrap parts. I'm trying to think what you mean by that. Because the bootstrap is just a resistor and a capacitor. So if it's the capacitor, Maybe you're on about, oh, I think I know what you mean. Do you mean capacitors that look like this? Because they should have a number on one side of them. They have the model on one, or the specification and rating on one side. I had 3 4Ks and they blew. That damn. What kind of flux does your solder have? Good question. Tin lead. It doesn't say. No idea. But it works really well, and it's what I've been using for the last two years, and I haven't had any corrosion issues, so it's pretty good. Joseph Young, reverse polarity hookup in a poorly lit garage from fried 7 FETs. Power and ground inputs are given a shorter signal. Is that normal for my situation? Yes, absolutely. So Joseph Young, you will want to replace all of the power supply FETs, not just the ones that died. So you want to replace all the power supply FETs. Also, check for big diodes like this by the power terminals. They will likely be shorted or damaged if you wired your amplifier in reverse polarity. This amplifier looks like it might have actually been wired in reverse polarity at one point in its life, because there should be 3 diodes that go, that are across the power terminals backwards. So they sacrifice themselves if you reverse polarity the amplifier. It looks like here, I don't really know what's going on, whether this used to be a diode and it's lost. I think that used to be a diode, but it's lost its case because it's been blown and one of them's missing. So yeah, it looks like maybe this one was wired in reverse polarity at one point in its life as well. That's the parts that usually die. You'll also want to check the power supply drive transistors. In a bad situation, you'll lose those as well from going backwards polarity. I'm thinking about switching the 2 monos for a B20 from Giant and Go 0.5, but currently I drive both coils at 1, haven't measured box rise yet. What subwoofers are there? I can't remember, Jim, what you're using. If they're efficient subs and the box is on the larger side, then you'll have no problems. 13 BTRX3, his boss may be a new viewer. That's quite funny. I always like getting new viewers. Yeah, hi Jesse. Jesse sent me a lovely message the other day, so thank you. Hi Jesse, good to see you on the stream. Alright, too much live chat, not enough board repair. So, my power supply wires are now in. Now I just need to go ahead and turn the power supply on. So let's go ahead and change the camera view. Put the power supply, switch that on. Now I'm going to put it on low current first, because there could still be something that is shorted out on the board that causes there to be leaking through the drive circuit here. So let's put a low current start with. And we're drawing 0 amps, so it doesn't look like there's anything leaking just yet. We haven't applied the remote yet, so I'm going to go ahead and take my oscilloscope probe, and we want to probe without hitting the remote first. Just make sure that we have our, in this case, 9.4 volts present on the center pad of the power supply MOSFETs, which we do, and we should have absolutely 0 volts on the gate pad. If we see the oscilloscope even move a tiny bit when we touch the gate pad for the power supply MOSFETs, then that means that the power supply drive transistors are leaking and damaged. Looks good so far. Doesn't look like we have any DC anywhere on any of these gate pads. That's a good sign. So the drive transistors may have survived in this case. Cool, so we don't have any DC on any of those, so let's go ahead and apply the remote, and let's make sure that we have good drive waves on these gates. That looks nice. Cool, so let's just make sure we have good drive waves on every bank. Now this amplifier has 2 transformers, and each transformer needs a push and a pull set of MOSFETs. So on each side we'll have push, pull, push, pull. So there's 4 different banks of our power supply MOSFETs in parallel. So we need to check 4 times for the drive wave to make sure it's equal on every one of these banks. So that is that's a 4.1 volt RMS square wave. So that's that bank. Oh, that's a 5.2. Okay, so although the square wave looks good, this is really important, and I'm glad that this has happened because this is really good to show you guys. Really, really good info to show you. Okay, so if we have a look here, I've got 4 banks of these FET locations, all with square waves on them. The first one that I measured has a square wave with 4.1 volts on it. The second one has 5.2 volts. The third one has 5.2 volts, and the last one has 4.8 volts. Now, that's either because the drive transistors themselves are going bad, or it's because the gate resistors have gone out of tolerance. Now, if we have a look on the board, we can quite clearly see that the gate resistors have most likely gone out of tolerance. They're absolutely burnt to a crisp, so they are probably no longer a 22 ohm gate resistor, which I think is what this uses for the 064Ns. So this should be around about 22 or 47 ohms at most. And the way that we can check, before we even take our multimeter to it, before we even read the resistance on there, we can check the drive wave before and after the gate resistor to see whether it loses considerable voltage. If it does lose considerable voltage, then it's too high a resistance. So let's go ahead and turn it on again. So this one over here that I probed, this has a 4.1 or 4.2 volt square wave on it. If I go behind the resistor before it passes through it, I still have 4.2 volts. So that shows that it's probably not the resistor that is causing that lower voltage square wave. It's probably the drive transistor itself that is faulty. So before I even remove any of these, we can clearly see that there is problems with the drive transistors. If we go ahead and check the other banks over here, we have 5.2 this side before and after the resistor, even though the resistors look very bad. Over this side we have 5.2 before and after the resistor, and this final bank over here we have 4.9 before and 4.9 after. Okay, so the issue here is mostly to do with the drive transistors. We need to go ahead and change those out, but we also want to change the gate resistors because they look pretty shit as well. Oh no, Joseph Young only had his amp for 4 days before he reverse polarity'd it. That is not fun. I feel for you there, brother. I feel like amplifiers should come with a bit more protection for reverse polarity. Do you know what I mean? It's like, it's a 50-50 thing. There's so many people that do it. Like, you can't see what you're doing. Your brain has little farts. And even if you've been doing audio for years, you know, you can just have one of those moments where you just put it in the wrong way. It happens, man. Shit happens. Humans aren't perfect. And for there to be such a catastrophic failure from such a simple mistake, I think is a little bit crappy. I feel like Hi-Am should have a bit more protection against that sort of thing. But there you go. So, these drive transistors then, we need to go ahead and replace those. So, on the board here you can see that there are a total of 8 drive transistors. Now, these will be PNP and NPNs. The drive transistors, what they do is they take the output of the TL494 chip. There's a chip on here called a TL494. This generates the square waves. This generates the outer phase square waves on pins 9 and 10 for the MOSFETs. But because this chip is really tiny, it can't drive all of the MOSFETs itself. So it has to be helped out by some drive transistors. And all these do is they just buffer or amplify the current of that square wave so that when it goes to the MOSFETs, it actually has enough oomph behind it to drive all those MOSFETs. So the NPN, which is the transistor marked with a C, in this case it's a C3228. This is the one that actually does the amplification of current for the square wave so that it can be driven to the MOSFETs. The other one, the PNP, which in this case is an A1275, and the PNP will generally always have the A marking. All this does is it just pulls the wave down to ground once the wave is turning off, once it's on the downward slope. The PNP then grounds that, and so that it turns all the MOSFETs off really quickly. The MOSFET gates have their own capacitance, and it can cause the MOSFET to stay on longer than intended. So you have these PNP transistors here to turn the MOSFETs off nice and quickly once the wave goes to an off state. So here we see we have the NPNs on the outside, C, 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 and C, and the PNPs, A, 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 and A on the middle. So now that we've got that into our head, which way round they are, with the PNPs in the middle, I can go ahead and flip her over, and we're going to go ahead and desolder all of this and replace. Yeah, there's even some rust corrosion marks on the bottom here of the board, so I think it's a good idea to replace these anyway and just freshen up most of these solder connections. When this actually gets in focus, you can see here there's lots of kind of rusted solder connections on the back here, and if we go, I think there are also, I think this is the worst place for them. I think over on the output side, that's generally looking okay. The worst place for this kind of rust and corrosion appears to be over in the power supply drive circuit. Okay. Zikan, thank you very much for the very kind donation, my friend. 20 at Swedish krona, I believe. Nice to see you live again. It's nice to be live. Thank you very much, my man. Jim has a custom B2 XM12s currently in a small box, but I let Harwood Acoustics design a 6th order. Nice! 6th orders don't generally yield a massively high box rise because 6th orders load the cones twice on the back and front, obviously, of the cone on with its cycle. So generally the impedance rise is a touch lower with a 6th order than it would be with a ported box. But those B2 subwoofers are very good and nice and efficient. So, personally, with the B2 amplifier that you've got being a very nice, strong amplifier, I don't think you'll have any issues running that at 0.5. If you have access to a Dayton DATS V2, it'd be interesting to do a sweep on there to see where your impedance null is, or hook up an ammeter to, I'm trying to think of the best way to do this. Trying to think of a really cool way for you to see it. Actually, here's what I've just come up with a cool idea for anyone that wants to find out where their impedance is the lowest. It won't tell you what ohms your box is playing to on reactor, but it will tell you where the lowest impedance point is, at what frequency. If you temporarily hook up your bass amplifier with a high power car bulb in series with the power wire, so don't put your power wire straight into the amplifier, you only need a very small bit of wire just to go put a bulb in series with the amplifier. And what you want to do is you want to play a tone very, very, very low volume, like literally you can barely feel the subs moving, because if you play it too high then the bulb restricts the current going into the amplifier too much and it will turn off and go into protect. So what you want to do is you want to play a tone that allows the subwoofers to play and enough current to pass through the bulb. Now the bulb will get brighter the more current is drawn from the amplifier, and it will get dimmer the less current is drawn from the amplifier. So if you play a sweep from 20 Hz to 40 Hz, at some point during that sweep the bulb will go from dim to bright to dim, and the bright point is the point where the amplifier draws the most current, which is the point where the impedance is the lowest in your build. It won't tell you what impedance that is, but it will tell you where the impedance null is, which is useful sometimes. I don't know. Azim says, I'm excited for this. This is my first live attendance. Nice. Well, I hope this is somewhat interesting to you. This live stream is going quite slowly because I'm doing lots of live chat. One moment while I take a quick call, please. So yeah, let's go ahead and remove those drive transistors that are not looking too good. Sam, I've got a Vibe VP4 that I picked up used. There's a strange problem. When I power it up and put a cheap sub on it, it sends DC power to the sub and blow the sub within seconds. Ah shit, that's not good. So DC to the subwoofer, that is a multitude of faults can cause that, but the most common problem with an amplifier that's sitting DC to the sub is a blown output MOSFET or a damaged drive circuit for the output section. So what you want to do is you want to pull the back off that amplifier. Actually, well, if you bought it used and it's doing that, try and get your money back, because obviously it's blown. But yeah, if you can't get your money back, or if you want to try and repair it, then take the back off. Check the output MOSFETs for short circuits between legs 1, 2 and 3. If you find any short circuits between legs 1, 2 and 3, then you have a shorted output MOSFET. So you can go ahead and try changing all of the output MOSFETs first. Don't just replace the one that you find that's short. Replace all of the output MOSFETs together as the same batch. And yeah, then try and power it on again. If it blows them again, or it does the same thing, then the fault is with the drive circuit and it's a lot more complicated. And I'll be happy to assist you if you decided to go ahead with attempting to repair that. Because there's so much corrosion on the back of the board here, it actually makes the solder very difficult to stick to anything. There's like a layer of, well, I don't know, of shit, basically coating everything that you can't see, but it's quite clear because the solder doesn't, it's almost like you're trying to solder onto sections of the board that don't have traces on them. You know that, the board repels solder itself, doesn't it? Like if you tried to solder to this kind of orange part, it just repels solder, it doesn't stick to it. So it's kind of like trying to deal with that. So I'm just literally loading up a bunch of solder all over the place on here, just to let the solder and the flux just clean up and get rid of any of that crap on there, because we're removing these parts anyway, so it doesn't matter too much. Once we've removed these parts, we're gonna use our alcohol and other bits and bobs, toothbrush, to really clean up this section properly. But this will help us remove these transistors initially. And they always bend the legs down, so what I'm doing is I'm just cooking it up with loads of solder, and I'm just bending the legs upwards so that they come out easier. So now we take our solder sucker, oh, the live chat is really delayed today, like it sort of updates it periodically. Yeah, the bend the legs really annoying. Joseph Young, thank you very much for the donation again, my man. Thank you for doing these live vids, incredible, valuable information. Cheers, buddy. I really appreciate the donation there, my man. I hope that is useful to you. Okay, that's all the solder out of one bank of those. Giant has a Dayton speaker measuring device. Yeah, that's probably the DATS V2. Yeah, that's a pretty cool piece of kit. You can use that to work out your box rise. The only issue with the DATS is that obviously it doesn't send much power to your sub, so it doesn't really get them moving properly. So the impedance rise will change a little bit with cone displacement. The higher the power going into the sub, the impedance rise will differ slightly at different power levels. The DATS V2, I'm not sure if that's quite got enough power to give an accurate representation of box rise, but it will give you a rough idea for sure. Man, this is proper janky. This is proper janky. Okay, now what we can do, flip the board over, And we can take some pliers from one side, go ahead and grab these jank-ass transistors and see which pin is still in the board, preventing it from coming out. In that one, that was free already. So these should pretty much just come straight out because we've sucked most of the solder away, but because this is such a corroded area, the solder isn't flowing too nicely, so there might still be some tiny little hairlines of solder that are holding these in place. So I don't just want to go and yank them out willy-nilly because I'll pull the traces out, pull the vias out, so I just want to be somewhat careful with it. And there we go, that's 2. That's 3. Most of these actually are completely loose already anyway. That's 4. That's 5. That's 6. 2 more to go. Seven. 1 more. There we go. All gone. Right, now let's clean this crap up. Got some small monoblock Kenwood Class D amps I could use your help on. Tim, shoot me a message on my BearViz Facebook page and I'll see what I can do to help you with that. I have an amp that goes into protection whenever I hit a pothole. That sounds like vibration damage on the... the most common place for that sort of thing to happen is on the output inductors. So the output inductors, they rub their leads or snap their leads off the board with vibration, and so that's probably what that is. But what you need to do is open up the board and take it out of the case completely and give the inductors a wiggle around, see if you can see if any of the leads are snapped off, or it could also be the rectifier legs have also snapped. Once you get the board out, usually vibration damage issues kind of present themselves quite nicely. You can see it quite clearly. Right, so on this amplifier, in this one, because of the corrosion, where are we? Because of the corrosion there, you can see that some of the solder points have actually disappeared on the bottom here. They were eaten up by the corrosion. So what we're going to have to do is, for those ones, they do need solder, but the trace for those is on the top of the board here. So what we're going to have to do is we're going to have to put some new transistors in and have them quite long on the board, and we're going to have to solder them from the top and the bottom of the board to ensure that the trace makes a connection to the top and bottom where it should be. Gonna shoot it back to the amp repair guy. Ah yeah, good idea. Do that. Finally made it, big country, to one of the live streams. I have a voltage drop from around 14.5 to 12.6 with 3 batteries, Optima, and a 190 amp alt. Would an X's power bank fix this? Is this at the voltage drop? Is this voltage drop dangerous? So basically, the voltage drop from 14 to 12.6. That's your alternator. So what's happening there? So batteries, they don't provide any current really above 12.6 volts. They provide their current at under 12.6, 12.4, depending on what batteries you've got. So the initial voltage drop from alternator charge voltage to battery float voltage, that is down to your alternator. So capacitors could help that out, because capacitors don't have, like, they're not like a battery in the sense that they charge at a certain voltage but they supply current at a certain voltage. They will supply current at whatever voltage you fed into them. So if you've got capacitors sitting at 14.4, then the current's there ready to go at 14.4. But if you've got a 190 amp alternator, then, and it's dropping that heavily, it depends what you're running. If you're running something pretty big, then you know, if you're running something pretty big on that, then yeah, that may be killing the alternator. But if you want to hold your voltage more steady at 14.5, then it would just be alternator upgrades. Also check your voltage at different points in the vehicle, because you could have voltage drop due to poor cabling or poor connection points. So put a voltmeter on the alternator output and then at the amps, and see whether there is any huge difference between the readings at both of those points. If there's differences between those points, then the voltage is being lost somewhere in the cabling on the connections to get there. I've pulled out so many rivets out learning how to do solder. Yeah, absolutely. That happens when you first start out. Okay. So let's get this cleaned up a little bit more and put our new drive transistors in, and then that should be ready for new gate resistors and new power supply FETs. I was trying to get my Zoom cam working, but it didn't seem to want to work today. I just had a black screen and I haven't really got time to fiddle about working out why. So at the moment, the only cameras that I've got is this front camera. I've got my head cam with a smiley face. I've got the side cam and I've got the scope cam. I think that's it. And obviously you've got the power supply cam to the left of the screen there. Okay. This isn't the worst condition drive circuit thing that I've ever seen. I've seen far worse than this, like from burnt, not from corrosion, but from burnt, I've seen far worse than this. Okay. Now that the drive transistors are out, I'm going to take the opportunity to clean up that area a little bit more with the isopropyl alcohol. Just because they were getting in the way a little bit earlier. Got a solder ball that's fallen down here. Get that out of there before I forget about it. So let's go ahead and clean that up a little bit more. Now that those transistors are out of the way. So you can see, like, those resistors that looked burnt, they're actually not burnt, they're just covered in soot. Because they clean up really quite nicely with the alcohol. The diodes are starting to shine again, the glass diodes. Yeah, much better. Alright. New power supply transistors then. Drive transistors, where you at, fool? Here we go. I'm running a little low on these. So we need 8. That's, so we've got a NPN, NPN, PMP, NPN, PMP, so that's 4 NPNs. I need 2 more PMPs and then we're good to go. These two are slightly different revisions. Quite like to find some identical ones if I can. That's a different batch. With drive transistors, you don't have to match up the batches, but it's nice to, if you can. Okay, there we go, that'll do. So, the NPNs were on the outside, weren't they? They were on the outside, so let's go ahead and stick those in there. And the PNPs were on the inside. Now these are going to stick up from the board quite a lot, so I can solder from the top and bottom of the board. Now I'm gonna I think I'm gonna solder them in 2 by 2 here, like Noah's Ark, so that I can get my soldering iron in there. And I'm gonna swap my tips out on my soldering iron to something a bit more delicate that I can get in there nice and tightly with. I'm gonna go for a fine tip, and this fine ass tip has a little bend on the end which allows me to get into tight spaces, which is very useful. Chris says, I've been missing your streams, man. Welcome back. It's good to be back and good to see you here, Chris. What's the best solution to clean the PCB with? I use 99% isopropyl alcohol. I know this webcam sucks and you can't really see what I'm doing, but my Zoom cam was not deciding to want to work today, so... The way that this solder is flowing in is so satisfying, especially after seeing the state of these vias earlier. Okay, that's 2 NPNs sitting pretty. So let's take 2 PNPs and shove those in. The PNPs that I've chosen, I think I trialed them on some other board that had a different pin configuration. So as you can see, I'd had at some point in their life flipped these legs round, but then decided that it wasn't the best way to go, so I probably ordered the originals. So I just have to bend these back and annoyingly clean the solder off of the legs before I put them in. So these are still pretty much new, but maybe I fitted them and then decided not to use them in the end. Can't actually remember, this was such a long time ago now. That's one gone in. Let's do the same to the other one. Spin those legs back to where they should be. Very early on in my amplifier repair adventures, I was working on a Sundown, I think it was a 3K, and the markings for the drive transistor location on the board were very confusing. They were kind of backwards to most other brands, most other boards, and so you actually put the transistors in kind of backwards to how it looks like you should on the board. And I shit you not, this amplifier caused me months of headaches trying to figure out why I couldn't get the power supply working. Because as far as I was concerned, you know, I'd put the new drive transistors in, and they were the correct way round as per dictated on the board. I just couldn't get it working for months. I was like, what the hell's going on? I just thought it must have some horrific problem with the board itself or something. I was like, yeah, geez. So I put it to one side for ages. And it was only when I got another identical amplifier eventually in for repair once again. And I looked at the markings on the board and the original drive transistors that were in there, and I was like, hang on a minute. That's backwards to how they normally are. And I looked at how I'd put the ones of the board that I couldn't get working in. I was like, oh, what the fuck? They're backwards. And it was then that I learned about the way that some, notably sundown amplifiers, are marked on the board for their drive transistors. So all I did was flip them round and that bloody thing worked perfectly. It's a shame actually I haven't been streaming for a while because I've been working on a really interesting amplifier. I've been doing some work on a Digital Designs Z2B. That's right, you heard it here. DD-Z2B, which is a monster of an amplifier. It's a very, very good, large, Class D mono monster of an amplifier. And the interesting thing about that amplifier is there were no burnt or blown transistors. The issue with the Z2B was that the driver board was burnt up. It had like a bunch of burnt resistors and caps and stuff on it, but no burnt MOSFETs. And what was happening is when you tried to power the amplifier up, all of the MOSFETs would swing to negative rail, so you'd get DC negative on the speaker terminals. And I've been working on that for a few weeks now, getting closer to getting it sorted, but it would have been quite cool to have streamed that one. And I haven't been videoing it either. So perhaps what I'll do is, once the final parts come through for it, I will do a summary of what I actually did on that amplifier, because it's pretty interesting and it's a cool design. It's actually a little bit more simple to work on than a lot of other big amplifiers, because it only actually has what does it have? I think it has 2 banks in it. It's something really weird. It's like usually these big amplifiers, they have like many parallel banks of FETs and inductors and things like that working together, but in this amplifier there are only 2 output inductors, and I think one side is entirely low and the other side is entirely high. It's very strange. So I'll do a video on that at some point. Matthew, how's it going, my man? Please show how you plan to solder on the bottom of the board if the solder point has been corroded away. So, Big Country, if the bottom solder point has corroded away and there is no trace on the bottom of the board, then it doesn't need to be soldered to the bottom of the board, if that makes sense. So the solder only needs to be connected to the point on the board where there is a trace running off of that leg. So if the trace is running off the top of the board, then you solder to the top if there's no remaining pad on the bottom. And if the trace is running on the bottom and not on the top, then you only need to solder to the bottom, technically. Some of these things will have traces running off both top and bottom, so you need to make sure that their solder is connected to both top and bottom. But for these ones, there is either a trace on top or bottom. So what I'm doing is I'm actually just, because all of these solder pads are remaining and healthy on the top, I'm actually just soldering each of these to the top and then soldering to whatever remains on the bottom. But most of the traces are coming off the top board here, by the looks of it. That's the last 2 PNPs, so now I just need to put the last 2 NPNs, which are these 2. These are BD139s, if anyone was interested. The PNPs that I use for the power supply section are 2SB772, which are a very fast, high current drive transistor. cool, there we go. That's every single one of those legs soldered to the top of the board. So now I'll flip it over and I solder the remaining ones to the back. Do you ever listen to Screamo? No. No, not really. No. I do like rock music, but I wouldn't say Screamo is up there for me. Z2B is a 10k. Yeah, it does well over 10k as well if you feed it with a bit more voltage. The Z2B isn't on their website because they now have the Z2C, which is the latest revision of that amplifier. The best average is 7.5k. All of DD's big amplifiers, like the Z2B, Z2C, are all limited edition runs, so they're not on the website. They don't have any left at the moment. I think there is talk of potentially releasing another run of large sort of 10, 12k amplifier, be probably called the Z2D or something like that. Maybe because there's not really, DD have basically maxed out what can be done with that kind of board design. So the Z2C is pretty much as big and as powerful as you can go on a kind of standard kind of half bridge board design. You can't really get any more power out of it than what they've done with the Z2C. So to go any further, DD will probably have to commission a design of their own board design, and it would probably be a full bridge board design. And I think it'd be really interesting if they commissioned someone to design them a full bridge big Class D amplifier that was in excess of 12k. That would be really cool, but I can't see that happening anytime just yet. Have you ever worked on an old school amp, i.e. vacuum tube? No, I haven't done that yet. I basically learnt and started out with Class D. That's where most of my knowledge is. I'm not even that great at Class AB amp repairs. I'm not the best at Class AB amp repairs. I'm the best at Class D, half bridge and full bridge repairs. Not so great at Class AB yet. I mean, yeah, I can fix them, but like my knowledge isn't as strong. Like with Class AB, there's lots of components that limit current through sort of transistor sets, and like there's a bunch of, you know, there's like a Darlington pair, or there's like a whole bunch of like names of like sets of transistors that form a type of circuit that work together. I don't know all that shit because I didn't go to electronics class or anything. I just learned how to repair these Class D amps. That was the first and the main type of amplifier that I learned to repair. So that's where most of my knowledge is. I'm just trying to clean up this section now, just getting rid of any solder bridges that may have appeared, cutting off the excess length on the legs. We're going to take the isopropyl alcohol one more time from the toothbrush, clean it up so I can just have a look, see a little bit clearer what's going on. That's better. Okay, I think there's one solder pad that just needs a touch more solder, and then we can test it out to see whether those drive waves are now all 5.2 volts where they should be, rather than sitting down low at like 4.2, which is what we saw earlier, which is why we've done this. Cool. Okay, let's flip her over and let's put some power through it and see what the drive waves look like. Have you done any work on MA audio amps? I worked on one MA audio amplifier. And it blew because the MA audio amplifiers have this kind of mesh grill on the top, and so basically any dust or any small strands of wire that are floating around actually can fall onto the board, and that's what happened. It fell onto the board and it killed the power supply section inside the amplifier, I think. Yeah. And so I just repaired the power supply section of the MA audio amplifier. So I didn't actually get to repair the output section, which makes it an MA audio amplifier. All I did was do the power supply section, which is pretty generic, so not much to say there really. It made a fair bit of power. It was quite a lot of power at 2 ohms. Okay, let's see now then, on all of our 4 banks, do we have 5, I think it should be 5.2. There we go. So that's the first bank, and before we changed the drive transistors, that was sitting at 4.2. They've now got 5.3, so that's really, really good. That's on the first bank, and the second bank we have 5.3, third bank we have 5.3, and last and least, not least, 5.3. Awesome. So we have a identical 5.3 volt RMS square wave on all 4 banks, which means that those 4 drive transistors are working, those 8 drive transistors are now working perfectly. So the next thing to do is to change out these really bad looking gate resistors, because they are, looking very stanky indeed. But what I might do, just to speed up this repair a little bit, because I don't want to take up your time too much by just replacing resistors, because that's pretty boring. I want to move on to the exciting output section. What I'm going to do is I'm just going to find some resistors that are close enough that remain on the board. I'm going to load up with 4 power supply MOSFETs, 1 per bank. So we have 2 transformers, which means that each transformer needs a push and a pull. So that's 2 times 2 is 4. So we need 4 individual MOSFETs on the board here to actually enable the output section. So before I replace these resistors, I'm going to go ahead and find the best locations to put them in, so that I can just power this up for you and show you it working. So it looks like these are actually 47 ohm resistors on here. So if we go ahead and see there, we've got 46 on there. Usually with, oh, hang on a minute, usually a resistor blows up, not down. What the? Oh, okay. I think these, because they're burnt, so I can't actually see the original. I can't actually see the original markings on the resistors, what they should be. I was going to say, usually with a 064N, you have a 22 ohm gate resistor. These are all over the place. 31, 48. 36. Alright, I'm going to choose the 4 that have the lowest ohm, just to show you this working. So that's 46. And obviously I'll replace them out with 22s once I complete the repair, but I just want to get the output section working out. It's 41. 40. Alright, so this middle one's the lowest one there, so we're going to go for middle. 30. 33. 26. 26. So I'm going to go for middle on this one, this end on this one, 36, 44, 38. That was nothing. So we're going to go for the third one in on there, and this side we're going to go for 48. This one we're going to go for the end one. Right, so I'm just going to go ahead and drop 4 MOSFETs in this just to get it up and running in the output section, so we can continue with the more exciting part of the repair. And then once the stream is finished, I'll go ahead and change out those resistors for some 22 ohms. How does a Sound Digital 35K in a package the same size? Because it is using modern MOSFET technology that these amplifiers are on. These amplifiers are based on a circuit design that is around 20 years old. So the Sound Digital is based on a circuit design which is only a couple of years old, or maybe a bit older, but yeah, it's a much more modern circuit design. It uses way more modern MOSFET technology, so you need much less MOSFETs for the same current handling. It's just a much better design, more modern. You can get much more current from a lower number of transistors. I've got a Kicker ZR1000. Someone tried to fix it. I've been struggling to repair. Class AB definitely isn't as simple as these Class Ds. See, many amplifier repair technicians will say that they find Class ABs much more simple. I personally find them a little bit more tricky to repair. I'm working on a Fender Champ right and left era 1950s. Holy shit, man, that's old as hell. Yeah, I wouldn't even know where to start on an amplifier like that personally, because it's not what I've learnt on. Okay, let's just drop some MOSFETs in here then, and let's get the output section up and running and show you what we got going on over there. So let's take some 064Ns. I'm going to go ahead and take some 064Ns that they don't have to be matched because they're in different batches, and I don't particularly care either. They're just old used ones that can blow if they like. I don't care, because it's just about getting this up and running for you real quick just now. So we've got 1, 2, 3, and I need one more. 064N, where are you, my friend? There we go, there's one. Cool. So 4 064Ns, let's go ahead and drop these in. Robert says the amp house work on operates well. Thanks for your advice. Good stuff, man. I'm glad you got it up and running. Very satisfying when you get something up and running that wasn't before. Okay, that's those pads prepped. This is just going to be a really rough connection for the minute, just to get this up and running, to show you the output section. That's one. Okay, there we go. So now I've got 4 MOSFETs sort of somewhat attached here. They're all attached to the right places, so that should work just for this purpose. Now, Now that we've done that, let's turn our attention to the output section of the amplifier, which is the most fun and complex part of the amplifier to repair. So, visual inspection once more, we can quite clearly see that we have some blown MOSFETs. So we have a MOSFET there that's lost its front, etc. So we're going to go ahead and have to cut these off or remove these MOSFETs that are visibly blown. And I'm also going to go ahead and remove any that are shorted. And that way we can see whether the drive circuit is working or not. So let's first of all snap this one that is quite obviously blown off. Now let's go ahead and check with our multimeter, put it on diode setting, and check for any continuity on any of the other FETs. Okay, so we have a shorted one over here, shorted one there, shorted. So these three are probably shorted. Let's go over here. Okay, yeah, short. Ah, that's interesting. And let's check over here. There's also some more corrosion over here by the looks of it. I'm going to have to clean that up. Okay, so no more shorted out MOSFETs over this side by the looks of it. So, but we do have some over this side. So let's go ahead and snap those off. Got 1 ohm there. 1.7. 1.4, 1.7, so it might just be the middle one. Let's see. It's all three of these. Okay, so that's all of the shorted MOSFETs out of the board. So the next thing that I'm going to do is I'm going to go ahead and just apply a tiny bit of power, a bit of energy into the output section of the board, so that I can read the rail voltages and see where they're see if they are where they are supposed to be. So on the rail voltages, they should appear on the legs or the pads of the output MOSFET area in a specific format if the amplifier is working correctly. I'm just going to go ahead and one of these solders came off on the power supply, one sec. So on the low side MOSFET we should have the negative rail on pins 1 and 3 and nothing on the pin number 2, should be 0 volts. And on the high side, on the high side of output MOSFETs, we should just have the positive rail on pin 2 and nothing on 1 and 3. So let's go ahead and start up the power supply. I'm just going to allow 2 amps to pass. Just 2 amps to pass at this point. I'm just literally going to just tap the remote wire here just to get the output section with a tiny bit of voltage in it. It would help if I plug my remote wire in. There we go, so just a tiny little tap there on the remote. And as you can see, that equated to some voltage on the output section. So if we take a look here, we can see that we have the high side here has positive rail on pin number 1. Sorry, positive rail on pin number 2, which is where it should be. Pin number 1 and 3 should have 0 volts on it. However, it looks like pin number 1 and 3 has negative voltage on it, which is not good. So pin 1 pin 2, pin 3. That either shows that some of these MOSFETs that remain in the board are still shorted or leaking, or the drive circuit is buggered. So the next thing that we need to do is remove the remainder of the MOSFETs in the output section so that we can identify whether it's the drive circuit which is down or whether it's the rest of the MOSFETs are leaking. So we've got 5 volts on the rails. I'm just going to go ahead and wait for that to sink down to 0 so I can touch my soldering iron on here. If you are bored of waiting for the rail voltage to sink down of its own accord, you can just short out the rectifiers, provided they've not got too much voltage in them, of course. You don't want to do it when it's got anything more than about 8 volts in it, otherwise you get a nasty spark. There you go, now we've got 0 on there. So let's remove those output MOSFETs and let's do the same test once the output MOSFETs are removed. We can do the same test once more. And that will tell us whether the drive circuit is functional or not. What time is it where you are, Seth? It is 20 past 5 in the afternoon. Has anybody else here been watching Final Space on Netflix? I watched the shit out of season 1. I thought it was brilliant. Season 2's Olan says season 2 is going to drop in about July or August of 2019, which is a bit of a wait. It's so annoying. I hate that because it's a relatively new TV series, so there's obviously going to be a fair wait on that. Ah, damn. I hate it when that happens. My desoldering pump has like shot off the end of it. It's gone somewhere under the desk. That happens when you get a little bit of solder stuck in the end and you go to reload the pump and it shoots the end off of the thing. Right, there's the spring. And there's the end. Hey Sam, it's Chevy's not Honda's. Had to change my name. There were too many questions about my name. Fair enough, dude. No worries. Does Ground Zero make its claimed power? Generally, no. It's a little bit under. So I think this 4K makes around about 3.5K. I have a metal pump. On those, the threading is stronger. Besides, it's double O-rings for a vacuum. Yeah, that's probably much better. I should really invest myself, you know, in between getting a proper desoldering gun. I should probably get a proper desoldering pump. Because this is like the cheap one that I bought and still had for like 2 years. But I kind of feel connected with it, you know, man. I've done so many repairs with that desoldering pump. It's seen so many things. Be kind of sad to retire it. How long does it take for you to fix an amplifier? When I'm live streaming, it takes me flipping ages because I'm always reading the live chat and explaining what I'm doing. But generally, an amplifier repair can take anywhere from like half an hour for something really basic, really easy repair. I know what to look for and small components. Anywhere from like half an hour to like 48 hours or more, like obviously not continuously, but broken up into like over the course of a week or a couple of weeks. Sometimes I'll have to put an amp to one side while I await parts, or I'll have to put an amp to one side, you know, just because I've been working on it for so long and I can't figure out what the issue is. I just got to come away from it for a bit and refresh my brain a little bit, do something else for a while, and then come back to it. So it really depends. Generally though, if there's no hiccups, if I know what the issues are and I know where to look, the biggest amplifier, like I say, if there's no sort of strange hiccups or anything, can take sort of 4 to 5 hours maybe maximum for from first dismantling it to putting it back together again. What's the cool looking sub behind you? That is an RE XXX V4. It's a very cool subwoofer. Not quite as cool as the V3, but still pretty cool. And it's just had a fresh recone. I just reconed it. Solder port to desolder pump is a good one. Nice. Where do you get your replacement parts? For amplifiers, I get them from RS Components and Mercatio. And very occasionally eBay, but I really strongly recommend not getting stuff on eBay. The only time I get stuff from eBay is like when the part doesn't exist anymore, it's not made anymore, and I can see that there's a somewhat trustworthy, reputable UK seller of said part. That's the only time I'll use eBay. Where does the Bearvidge channel name originate from? That's a good question. Well, essentially, the channel name has nothing to do with audio at all. So when I first discovered YouTube, I was, I think, 13 or 14 years old. And I was looking for somewhere to put some videos up online, some silly videos that we had taken from secondary school, just like mucking around in the classroom, or just like just being stupid kids. So I was, you know, back then there wasn't really any video hosting websites as such that would allow you to upload like a decent length of video or anything like that. And my friend told me about the YouTube, the website YouTube, and said, "Oh, there's this website that you can put videos on. It's called YouTube." I was like, "Oh, that's pretty cool." So I'll just put them on there. So my YouTube account was just made so I could share stupid schoolboy videos with my classmates from our secondary school. And the reason it's bear vids is because at the time, there's a slang word for many. So in the UK, the word bear, you know, among school kids around my time was used to describe many. So if your friend went to the shop and he came back with a huge portion of chips, you'd be like, "Oh man, you got bare chips there, innit? Oh, allow me a chip, man, you got bare chips." So, because obviously I had many videos to upload, I just called my channel Bear Vids, because I had bare vids in it, man. So that's where the channel name originates from. I actually hate the channel name now. I really don't like the name Bear Vids, but it's kind of stuck and everyone knows me as that, so I guess that's what it's going to stay. I have thought in the past about changing it to something else, but, you know, everyone just knows me as Bear Vids now, and fortunately the term bear isn't really slang in many other countries for anything else, so... Okay, that's all the output MOSFETs removed. These boards are really nasty to work on. The pads are really crappy and they're really shit amplifiers, these. Alright, so let's put the power back into the board and let's see whether that voltage that was present on the FET pads has disappeared. So before we removed all the output MOSFETs, we were seeing some high voltage on the low side drain, which shouldn't be there. So let's go ahead and put that back in, turn the power supply back on. Probe the output here slightly, and let's see what we got. Okay, so we've got some low voltage there, and there is still some high voltage on... There's still some low voltage on the high side gate and source. Okay, so even with all the MOSFETs removed, there is still voltage where there should not be. And yeah, there's still loads of voltage where there shouldn't be. So that means that the drive circuit is fucked, which means that we're going to have to go ahead and remove the driver board and replace the drive ICs, and probably also replace some other bits on there, maybe the bootstrap diodes and capacitors and other stuff. Yay! What car audio brands do you like? I like B2 Audio, I like Digital Designs, I like Alpine, I think they have some fantastic amplifiers. I like JL Audio, I have respect for them. I respect some of the Rockford stuff that they're doing, even if it's very expensive. What else do I like? I like Sundown to an extent. I wouldn't use it because it doesn't do what I want, but I like them still. I like JBL very much so. Cheers, Dan. It's good to be back streaming, even though it makes this amplifier take twice as long to repair. You've enveloped 2 speakers in the B. Set. Wait, what? Oh, I have. There's 2 speakers in the B for Bear Vids. Yes. Yeah, so that works. Do you use the DIY audio forum? No, I don't. Lunchtime. Thanks, Tom, for the content. Sound very educational and entertaining. Cheers. Thank you very much for tuning in. I'll see you next time, my man. Wolfram, I've never had experience with. Sundown amplifiers are just generic amplifiers from Korea or China. They haven't designed their own amplifier. The same way that DD hasn't designed their own amplifier, they've just made small changes to an existing design. So I can't really comment. You know, Sundown amplifiers aren't really Sundown amplifiers. They're just a generic amplifier that's had a couple of modifications done to it on Sundown's request. So what do I think of a Korean design half bridge? Yes, it's generally pretty good as long as it's been built correctly. And that goes the same for Sundown, DC, DD, Ground Zero, SPL Dynamics, etc, 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 all the other brands that use those boards. Do you repair rack mount amps? No, I don't at this point in time, unfortunately. I learned and started on car amps. I know I have tried a couple of home amplifiers and it hasn't gone too well, so I'm not quite at that point yet. So maybe we'll get there eventually. Not much vid on your bass van lately. I haven't done a lot with the bass van lately because the weather's been terrible. I've not driven it a lot, to be honest. So I'm waiting for the DDZs to break in a little bit further. Then I'll go and get some... I'm going to do a full tour of the bass van shortly. And I'm going to get someone else to do some videoing of it as well. To hold the camera, you need to get a cameraman up involved. So yeah, there's some cool videos of the van coming your way. But probably when the weather gets a little bit better. Okay, driver board. Now the driver board, many people who don't do amplifier repair all the time or just starting out in amplifier repair will make a massive mess of removing the driver board. And I have to actually probably admit, I think the first driver board I ever tried to repair on an amplifier that belonged to me was a bit of a mess as well. And that's because you don't get rid of enough of the solder. So what the best way that I remove these driver boards is go ahead and heat up every one of these and suck the solder from each one of these holes first, and you'll never get all of it out, not on every single hole. So once you've done this on all of them, what you have to do is wiggle the driver board very gently, just wiggle it back and forth and see which of the pins are moving freely. Any of the pins that aren't moving freely, that are still stuck with a bit of solder, then just go ahead and sort of heat it up and remove. Try and get it disconnected from the edge of the via so that it then becomes free and wiggles in the hole. And I'll show you that in a minute once I've actually removed all the solder from here. And if the solder's a bit old or it's got a bit of oxidization on it, a good idea is just to go ahead and run some fresh solder along all of these, just so that it gets sucked up really easy, just so it's all nice and fresh. Because yeah, the solder on this it's like something really oxidized. It's got like a layer over the top of it, so my new solder doesn't really stick to it that well. So yeah, let's go ahead and just run a bunch of fresh solder over there. See, now it's melting much quicker, and now when I suck it, it actually sucks up the majority of pretty much all the solder in that hole now. And there's one pin here in the middle. That's my doorbell. There's one pin in the middle here, which is the ground pin, and this has a very high thermal mass. I'm not sure if you can see it how well here on the camera, but see, this is the ground trace on the board, and this has a pin which is connected to it. Now, because that is such a large trace, that will soak up all the heat that my iron adds to this pin, making it quite difficult to suck the solder out of it. So the idea is to heat up the trace first over here with your iron to get this part of the trace really, really hot. So then when you heat this bit, it's not soaking away so much of the heat, and all the solder gets sucked out just like that. If you try and heat it just from this side first, then it won't. It will just the cold trace will just suck away all your heat, and the solder won't melt, or it will cool too quickly, and it won't get sucked up by your solder sucker. Okay, so that's the solder removed from most of those holes. So what I'm going to do now is just drag it over the edge. I'm going to wiggle it very slightly. So you can see some of these pins are loose in the holes, but some of them are not loose yet. They're still attached. So any that are still attached, I'm going to go ahead and just shift the driver board to the side slightly, and then go ahead and resuck any that are still attached and not fully wiggly. There we go. That's nice and wobbly. Actually, they're all looking really good. Yeah, I think there was just one that it was still attached to. All the rest of them are nice and free. So that's really good. So you can see all of the pins wobbling equally, and there's no resistance on that. So if I turn the soldering on off, flip it over, you can see here that now you can see how like wobbly that is. It's just so loose in there. So now I should just be able to give it a little tug, You don't want to pull mad hard. It should just kind of come out relatively easily. If there's loads and loads of, there you go. If there's loads and loads of pressure on it, stopping it from coming out, then there's a bit of a veer that you're trying to pull out at the same time. So yeah, there we go. Doesn't look like there's any veers pulled. We've got one top ring on this one that came out, but that doesn't have a trace on the top, so that's no problem. Cool. So now that the driver board's removed, in theory, by powering the board up one more time now, just very slightly, we shouldn't have any of those voltages present where they shouldn't be. Because the driver board is the thing that has the shorted chips on it, which is causing the voltage to leak where it shouldn't be. So, just as a final check, let's put those in here. You see, I had the polarity backwards then, but because I have I told you how easy that is to do. How easy is that to do? How many amplifiers have I repaired in my time? Yeah, and no matter how experienced you get, all it takes is me talking and chatting and shit and not fully paying attention. And yeah, the wires will reverse polarity. But because the power supply is only allowing 2.1 amps to pass, that will have done no damage whatsoever, and all of that tiny bit of voltage just went through the diode here. So yeah, no problem at all. So let's go ahead and touch this on here and see whether we have any voltage where it should be or not. Okay, great. So now it looks like we have on the high side positive rail on pin number 2, which is correct. Pin number 1 and number 3 have 0 volts on them. Perfect. So that's got rid of that. Let's just check the low side. Should have negative rail and nothing in the middle. That's correct. Over the other side we have high side with nothing on 1 and 3 and low side with nothing on 2. Perfect. So yeah, that's got rid of our leaking voltage where it shouldn't be. So the issue is on the driver board now. So let's put the main board to one side and let's focus on the driver board repair. Okay, so annoyingly this would be a great opportunity to use my zoom camera, but it's not working at the moment, so that's a shame. Now, the driver board, if I put it onto head cam, that might be best way to show you this. Let's get rid of that. What we've got in the live chat. Okay, so the driver board, as you can see here, we have a couple of IRS 21844S chips. When it focuses, come on, that's it, here we go. A couple of 21844S drive chips. So it's a good idea to change both of these. One of these is definitely dead, and that was the one on this side, because this side of the amplifier had the voltage where it shouldn't have been. So we need to go ahead and replace that one. And I also want to check whether these diodes D1 and D3 and CL1 and CL4, whether they're shorted as well, because they can also be damaged when the MOSFETs die. There generally isn't much else on these driver boards that will fail every time the amplifier fails. In rare extreme cases you might find resistors, capacitors and small SOT23 transistors on here which are dead or shorted, but it's quite rare. Usually you just have to change the drive IC and it's good to go. So let's take our multimeter, actually no, I'm going to go ahead and remove the chips first. So to remove the chips, let's take a hot air desoldering station here, and I'm going to put the temperature up to about just under 400 degrees, so about 388, and I'm going to apply a little bit of flux to the chip to help it to come off and help all the solder to melt nicely. Where has my, here it is. There we go. And take my smaller tweezers. Yeah, Yeah, this usually looks much better on the zoom cam, but it's not working sadly. In your opinion, with what experience you have, what amps would you say are built with the highest quality? So in terms of build quality itself, like seating everything down properly, really nice, like no vibration damage issues, great board thickness, etc, etc. It's gonna be possibly Genesis, possibly some of the JL audios, although a bit questionable on the preamp section. Actually, one of the best build qualities that I've seen of a common amplifier is actually a JBL. Believe it or not, the GTO 14001 has superb build quality. Honestly, it's an extremely well built amplifier. MTX, yeah, also built pretty nicely. Robert says his Hakko desoldering gun makes life so easy. Oh man, you know, I'm just going to have to bite the bullet and invest in one of those. I've been saying this for, what, maybe 8 months to a year now? Ah, that's a great Christmas present idea. Screw it, yeah, I'm going to put that on my Christmas list. Not that anyone's going to buy it, but maybe I'll buy it for myself for Christmas. Okay, now slight conundrum. I don't think I have any brand new drive chips. I have a bunch of used ones here. But I don't want to use a used one because this is going back over to Europe. No, I'm actually gonna have to order some new drive chips. I've got a big pile of ones up here, but they're ones that I've pulled out of amplifiers where it didn't kill that chip, but they are still used, so I don't want to put them in this amplifier. I'll put them in amplifiers that I repair for myself, or you know, if someone wants it doing really cheaply or something, I'll let them know I'm using used parts. But for this guy, it needs to be 4 brand new drive ICs. So unfortunately, I can't go any further with this repair today because I need new drive ICs, and I don't have any at this point in time. But I can probably move on to another amplifier. But that'll be after dinner, I think a little bit later this evening, to give the Americans a chance to join in. What do you think about the Orion HCCA amplifiers? The new HCCA amplifiers are, you know, the design is not bad in the sense of the components they use are good. It's using good new modern MOSFETs. The drive circuits are very strong. The board layout is good. It's a good PCB thickness. It's a good build quality. However, the new Orion amplifiers, they have not designed the drive circuit correctly to deal with the differences between MOSFET gate capacitance between the same batch. So what happens is that one of the Orion amplifiers, of all the MOSFETs in the output section, some of them will run really hot because they are not in tolerance with the one in parallel next to it, and as a result it's driven slightly differently and it fights with the parallel one next to it. And this is an oversight on Orion's part. Well, not Orion themselves, but whoever designed the amplifier, probably. I think it's a Korean full bridge. And the same goes for the Vibe and the DS18 and the Edge full bridge mono amplifiers. There is a design flaw in the output drive circuit, and they you know, you get one that's fine because it just by chance got all similar gate capacitance FETs in it. However, you might the next one off the production line might have had FETs with quite a varied gate capacitance, and as a result it runs really hot and is quite likely to fail. Yeah, cool. Right, I think we've had a really good stream so far this evening, guys. 0 dropped frames as well, which is pretty crazy. 0 dropped frames, and that is from a LGA 775 machine running DDR2 RAM and a 560 Ti. Yeah, still rocking a 775. So I'll pick this stream up. I think I'll probably do some more streaming later this evening. So depending on what country you're in, that may probably be later in the afternoon for you, or maybe at a better time for you in the evening. I'll pick this stream back up and we shall look at another amplifier. Try and see what else I've got laying around that I can show you to repair. Oh, I know what would be a really good amplifier to do on live stream, and that would be an Orion D5000 with a PIC failure. So the D5000 is where the PIC, the programmable IC control chip fails. Those are, you can't get those chips anymore. So I'm going to look and see whether I can go ahead and bypass that chip and see if we can get the amplifier up and running. What happens to better, ground zero or base phase? Ground zero every day. Yeah, ground zero, they're not the best, but base phase are one of the worst. Yeah, cool guys, thanks for tuning in. Stick around a little bit later on today if you want to see some more and prepare live streams, or I will try and do some more live streams as time goes on this week and next week, ongoing over the Christmas period into next year. Have a good one, and I'll see you soon.